Welcome to today's presentation for Revit to Advanced Steel collaboration via the SMLX transfer file. About me, a bit about my background. I've been involved in structural steelwork for a number of years now, virtually most of my working life, to be honest. Started off working in 2D, drawing things on a drawing board, etc., and then progressed into using CAD, 2D CAD, and then obviously moved into 3D detailing and modelling. I've been involved, I actually run a fabrication business for a while. I also got the opportunity to work with Advanced Steel about 16 years ago, working for a fabrication company. That led me to come and work to the other side of it in the channel, as they call it. And I've seen Advanced Steel change and progress over the years, and several different sort of changes along the route of that pathway. And we've had some more recent changes and more collaboration between Advanced Steel and Revit to help aid the workflow between engineers and detailers. And that's really where I'm coming from today. And my background at the moment is I'm heavily involved in trying to get this working for people and help them succeed. So a bit of an introduction and some stuff about the key learning today. So just going to play a short video here. This is a standard video that is available from Autodesk. It's actually done by a friend of mine who still works for Autodesk, and we've known each other for a number of years. He's obviously he was an Advanced Steel guy as well, so like myself, and he's still involved in it. And in the video we can see some of the nice new features that have come across into Revit for 2019. And those of you that work with Advanced Steel will know that these tools that you see in front of you here slightly different in their application and the dialogues, etc. But we're basically placing plates, bolts, welds, cropping a plate, shaping it, and all this kind of functionality has existed within Advanced Steel for a number of years. And now we see this being transferred across into Revit, which gives us a chance for more interoperability between the platforms. So a little bit about where this class came from. So we're trying to sort of look at how and why. You know, we get asked a lot of times on support, you know, what is the best method? What about the XML file? You know, what is an SMLX file? You know, how do we get stuff from A to B? Do we have to do anything? Oh, it hasn't come in. Can you advise us on how to change it? So that's really where the idea for today's class came from, was out of many sort of interactions with clients, support calls, etc., and probably some frustrated steelwork detailers having a bit of a challenge trying to get stuff from sort of engineers and stuff, been given this file and told everything's in the file, and then some of it doesn't turn up, or it's not visible, or it didn't quite work. And with the changes as well over the recent years, with the different elements that can come in and the different ways that stuff is transferred within this format. So that's primarily what we're going to focus on today. So some of today's objectives, you know, things that we're trying to sort of achieve from today is basically, where do you find the Advanced Steel extension and what is it? What is an SMLX file and how does it work? What doesn't get transferred? And obviously with 2019, 2018, I think 2017 we saw connections sort of creep in, and 2019 we see a few more bits and pieces creeping in with obviously the addition of the steel toolbar, which was just seen in the previous video. And hopefully I'll try and get a few tips and tricks in along the way of what we think engineering and detailing need to help them work together. So the extension between Revit and Advanced Steel. We always get asked this, where do I find it? Well, it's available on the App Store for, I think, 15, 16 and 17. I think, and 18. 19 is now in your Autodesk account. Yes. Are there any help files? Yes. Where does it get installed on the ribbon? Are there different versions? Yes, there are different versions. It's changed every year in the last 3 or 4 years because of the changes in the core software and the inclusion of connections, etc. And now the inclusion of the new steel ribbon tab with some of the tools that we would be familiar from Advanced Steel now appearing in Revit. So hopefully those of you get the PDF maybe electronically. There should be some help links which are interactive at the bottom of the page. So the extension itself, how does it work? What's behind it? So what format is it? Are there different ways that it transfers? So originally it started off as just a straightforward expressions formula. It was basically a database in the background. You had a section inside Advanced Steel. There would then be a formula that was written that could then express that and transfer that to another platform. And this format was used not only for transfer between Revit and Advanced Steel, it was used to transfer to other platforms as well. It's quite complicated for people to set up. So, and over the years we've seen that change into one-to-one mapping rules where you could map a section directly from Revit into Advanced Steel. So if you knew what it was called in Revit and you know what it's called in Advanced Steel, you could create a line for it. And that was sort of the next step. Then we've seen the section key come in where they've used the section name inside Advanced Steel, linked that inside the Revit families, and used that as the key name in the transfer process. So basically it knows what it's called in Revit, it knows what it's called in Advanced Steel. They sort of embed that in the code and in the approved families. And then more recently, the ability to transfer a custom profile as a dynamic section, and then in the background of all that you have materials mapping that is required as well. So hopefully we'll expand on all those topics as we go through today. So to expand a little bit here, based upon expressions, this was the first format that I remember seeing inside Advanced Steel, and it was used, and it did work, and it still works now, and people do use it. I have seen people completely empty the tables and create their own formulas from documents and stuff that they have all the information, and fundamentally it stores the information in a couple of tables inside the GTC mapping database. I would say this is not for the average user to be having a go at this. It's someone who has enough competence and understanding a little bit in the background. So it was quite difficult for people to do this, including people like myself. It did require a great deal of time and concentration to get through this process. So the second sort of stage for this is section sort of based upon it uses the section shape. So this is where the formula comes from. So as in both platforms you have a section shape, so a section code. Advanced Steel we have standard shape codes, we call them, and Revit has similar things where we have standard shapes, and those all have heights and widths and thicknesses and radiuses included in them. And this was the basis of the formula, and this was how it sort of worked. So they would map them and then use this as the rule between the two different interfaces. The section shape still does play a role in what we're doing as well. You'll find that coming in later on under the dynamic. So a sort of step on from that was the one-to-one sort of mapping rules. This is where you could take a profile inside Advanced Steel, and if you knew what it was called, you could select it, and you would do it via a mapping dialog. And to be honest, if you did one and you knew what all the others were, you could populate the table yourself in the background using obviously a spreadsheet editor, or you could actually do it directly in the database and adding lines in the database. And this is quite common because although section names appear to be identical, when you actually look at them in the different platforms, you'll find little changes, like the two examples in front of you here. If you look closely, you'll see that it says 89 with a lowercase x, 64 lowercase 8. And then the other one is it's 88.9 with a capital X, 63.5 X, 7.94. So the two would never tie up because the names weren't exactly the same. So this is why the mapping dialog would come up. This still works. This mechanism is still available inside Advanced Steel. So you can still use this if you want, and you still can add the mappings in manually if you so wish. And it also helps, I think, to use the country column as well in here. If you're doing it in a particular country and version, that can help track the entries as well, because there are similar sections used in different countries. So in this is basically the mechanism that's used when they use the approved families in Revit now. They use the section name that's in Advanced Steel and they map that inside into the Revit family, and this just makes it a lot easier. So if you are using the approved families, which there is a list available for them inside on the help pages for Revit, and we'll probably come on to that later on. But it just makes it easier for everybody to work. So normally, if you could use the approved families, which have all been linked, all the standard section types and codes, and this method does work to transfer between Revit and Advanced Steel and vice versa. And this is the basic transfer of the sections like columns and beams, and they do all have, as I said, the section key in place. The key tables for this is actually there's a database table inside the Aster Profiles database, and it's the Revit AS Profile Conversion table, and you'll see a list of the basically what the family name is inside Revit and what the actual Advanced Steel table name reference or group profile group is inside Advanced Steel, both linked together. So I would try and use, my tip is try and use the approved families where you can. It makes your life a lot easier. So again, I'm just gonna just play a little video. So this is me sort of modeling in Revit, and I'm doing a very simple model here. I've basically created a template in the background. You'll see this template throughout today's presentation, and I've loaded a bunch of the standard families in place inside the model. So obviously the UCs and the universal beams. I mean, I think we'll come on and say that later on, if you're working with steel a lot, then it's best to do that. And to be honest, I have created some material grades as well. This is why we have a few funny colours in here as well. I've done that literally for today's presentation just to make it obvious to see that what I'm doing from one platform to the other. So the beams are modelled, and obviously the materials are different, and you get a lot of the properties as well now come through between the different platforms. So, and I've used an approved family to do this. So I'm just using the extension here. I'm just checking the settings. I'm not going to change anything. I'm just going to leave it as the standard settings. The libraries file automatically does that now when you log into 2019. It auto collates what's in the library. the guys from Autodesk have actually put everything in one place now. You don't have to go and have it loaded. In 18 it was loaded in several different places. So I'm just overwriting a basic file that I created earlier on. So you give the file a suitable name. So I'd obviously created the file before it, and I'm just going to overwrite the file. I'm then going to swap to my Advanced Steel. And I'm going to come to, so I've opened a file in Advanced Steel, a template file, it creates a new one, and I'm just going to come to the Import button under the Export Import Ribbon tab. And this is the import button for Revit. I'm going to go and find the file that I just created, and I'm going to press the OK button. So we can see from that the columns come in, we can see the material gauge been transferred and the column size. And obviously I'm just going to go and check the beams here as well. And we've got a different material and a different beam as well. We've got another different material there. So this was the idea today, to just try and explain that this is a very basic transfer from Revit into Advanced Steel. So if someone's just doing a conceptual model, an engineering model, they can use this and then use it to transfer across to a detailer in Advanced Steel. And you can see we have access to the full database library of all the sections in there. And just to obviously reiterate the point, I've gone back inside the Revit and you can see the column size there, and obviously the material grade, and obviously you can see that I've actually loaded, it is actually exactly the same now inside Revit as it was inside Advanced Steel, with the library available for the section sizes. Obviously it depends on which country you're in, there are a number of approved libraries. And one of the other things here is I'm just showing the section key as well. So the section key is actually the trigger or the link between the two software platforms that makes it easy for this to happen. You don't have to do any mapping. If you use the approved family, it will work. So a little bit more about the sort of extension. This is what I call mechanism 3, but it's the dynamic method. Dynamic is activated by checking this tick box down in the bottom, and this, when it says custom profiles, it actually means profiles that are not of a standard sort of approved Autodesk family, but might be the same shape as something else that you use. For today's example, I'm using a cold rolled C-section as an example. It will transfer these into the model, into the Advanced Steel model from the Revit model. And what it does, it doesn't actually create any entries in the database. So this is where the profile doesn't exist inside Advanced Steel. It makes a representation of it which you can work with inside the system. And this is also utilized when they do the new steel fabrication format, working with connections in the 2019 version. So this means that companies that have created their own families, maybe I-beams or something with a slightly different name, or they've got a slightly different Kobe data or other metadata associated with it, can use that and still transfer it backwards and forwards, and it will come into Advanced Steel and be shown inside Advanced Steel. It's also a good method, I think, for sending a model to maybe a structural detailer stroke fabricator, and you might not be aware of what's inside Advanced Steel, so you could send it in this method and they could at least have a look at it, and they'd probably get most of it in and then go, oh yeah, I've got one of those, or we've got that family, or that section exists in Advanced Steel, yeah, we know what that is, we can change it to that. So it can be a good way to help get across stuff that's not possibly going to be inside Advanced Steel. So in this slide, it's just going to show a video of the dynamic transfer method. So got the same model in Revit. Again, I'm just going to add in a C-rail. So I picked a manufacturer from the web. They had a family available. I downloaded it. I've added it into the model. I'm just going to model in a couple of sections here, and these are like the C profile that I was showing in the previous slide. and I'm just going to set their material, I think, to a particular type in the system. So if you're transferring into advanced steel in the UK, at least, we tend to call things cold rolled. So I'm just going to transfer that across, and then hopefully get that set and model a couple of these sections in here. So you can see the difference in the colour there. I'm obviously sort of free modelling at the moment. Obviously you'd probably be a little bit more constrained if you were doing this properly. I just wanted to show some different options here, so I'm just going to change that. So I've got to change that back to cold rolled, I think. Yeah, that's it. So, and I'm going to change the position of these as well. So in advanced steel we have a thing called the system line. A lot of people call it the analytical line, but it's not quite the analytical line. It's how we position the steel. So in Revit you have a similar sort of thing, and that's what I'm doing here. Is I'm sort of moving it from the origin point. I'm sort of biasing it to the top or the bottom or the left or the right. And I'm probably going to leave one sort of roughly in the neutral point in the middle, hopefully. I think I'm going to set this one, yeah, from what I recall, yeah, I'm setting this back to the origin. So it's doing that for a reason as well. So this wouldn't come across, strictly speaking, because this is if you didn't know if the family existed or not. I would tick the that box there, but I'm going to try and export it in case this is what normally happens. People export it without doing any settings like this, and then they'll just send it across and create a file, and then the detailer will get the file, and then they'll obviously import the file, and we'll see what happens. So just creating a file with a slightly different name there. Just swap to advanced steel. I'm just going to create a new file, I think, just so I didn't get anything mixed up at this early stage. So, and with that I'm going to import the file. So obviously find the one which I picked, and we'll see this come in, and as I zoom down here you'll notice that the C sections have rotated. Now that's because I actually set a mapping inside the system to map the Albion C to the Albion C inside advanced steel. Now I knew we do Albion sections, so we have them in the database, but I mapped them and just wanted to see what would happen with the profile rotation. And this is what typically happens. People transfer it across and it just doesn't come out right. Now it's fine if you've got 3 beams, but if you've got 300 beams it's a bit annoying. So this is why if you tick with the dynamic here, it helps you get around this problem, especially with the positional data and the actual rotation of objects I've found in my testing. So I'm going to go and create the same file again. Just change the name of it slightly. So with the dynamic setting this time, come back to advanced steel, pop in and create a new file quickly, and then import again using the new file that I just created with the dynamic setting. And we can see that's come in. It's respected the positional data, the system line position. Okay, the things are rotated around the right direction. So at least the guy doing the detailing would probably have a better sort of start point. Wouldn't have to worry about the orientation of the objects, etc. There are a few funnies there. There's a few offsets in there that we normally wouldn't apply in advanced steel. We'd normally teach people not to do that. But in this case, it does put the system line where it needs to be. Now you'll notice a difference in the drop down here as well. We only have the one section available. That's because it's brought it in under the dynamic class. You can change it if you want to. There is a method to change it if you need to. That can be done. So you can leave it as it is. So you probably only need to change it if you need to change the size for some reason, or you specifically want to map it to something that you have inside the system. So I'm actually going to go and just draw here a little section of Albion C section. So under here we should have a drop down menu that actually goes to the C type of cold roll beam. It doesn't matter what the alignment is. I'm just going to come here and make sure that I'm in the Albion section. You'll see it slightly changed there. Make sure I pick the C section and change it to the appropriate size. So this is what you would normally see in advanced steel and what most people using advanced steel would be used to seeing. So with that in place, you can use match properties, which is an AutoCAD tool, but it does have extended functionality for advanced steel. So you can untick certain elements of the dialog so they're not affected. So in this case, I'm unticking the positional control because I want to leave it where it is. I don't want it to move everywhere. I'm going to leave everything else set, and then I'm probably just going to go OK to it. So, and literally just comes up with the sort of the AutoCAD stuff there, and then I just click on the objects. I mean, you can window select them as well if you need to. And if you go back in and look at it now, you'll see that it's actually changed it back to be a normal advanced steel family or profile class. So that's a little trick that I would recommend if you want to do that. You only really need to do it if you need to change the section size. Everything, all the other functionality is correct as far as I can tell. So another bit that comes up quite a bit is to do with materials. In advanced steel, we have an extensive materials library. It's a global library, to be honest, and obviously you need to sort of link that with the Revit materials. There is a certain amount of mapping that exists inside the system already that's been provided, but the thing is to try and get everything sort of in the right place in the right order. So with that, I found that it's probably best to look at the materials that you're going to use in Revit, create an appropriate name for them, maybe even look at what the steel suppliers are actually supplying, and then create that material inside Revit and use that material as your primary material for modeling obviously the steel. And then when my personal view is if you are going to transfer this to a fabricator, then maybe just give him a little schedule of what you've used, and he can check the advanced steel materials library. If you do create a material inside Revit and you have it inside the same company that someone's using advanced steel, then maybe advise them that you've done that, and they can create the appropriate material inside advanced steel prior to like importing the file, and with the correct naming in place, it will come in. It uses the key name inside the advanced steel database table, which is under the materials table inside the GTC. So it will work. It does cause a few hiccups, I've found, if you don't quite get it right, and just maybe just a little bit of forethought about your materials will help you transfer backwards and forwards a lot smoother. So just a little video here on materials. So inside the model here, this is the same model. We had the Albion here, and I drew them, and they just drew them in the normal steel section. But obviously I want to transfer them because I know in advanced steel we use a material called cold rolled, especially in the UK, for transferring purlins and rails. So under this you'll see that it says SJ275JR. So I'm just going to click in the section and change that in a minute. So if I look in advanced steel, I'm just going to look at a typical model, I think, just to show you that. Yeah, I do. So so here, this is just a typical shed that we have, something I modelled actually for today's presentation, and the material is called cold rolled. So to get that across, I want it to be in the cold rolled material inside Revit, so that it transfers it across correctly. I don't want it as 275 and then have to change it again when I get it inside advanced steel. So with that in place, I'm just going to look in the background here, and here I'm actually going to look at the materials table. Okay, so this is a materials table inside the database, and we can see the S references there for the 275, etc. And if we just scroll up and down a bit, we can see all the ones down at the bottom for the standard beams and that we've used to transfer backwards and forwards. So I have created some for today. You know, it mapped those in automatically, and you'll find some existing ones in here, and I think I'm just looking for the cold rolled one in here. So they're in using obviously the key of the table. So they're not always in they're not in alphabetical order. So I'm just having a little look around here, trying to see if I can see it. So I'm looking for 451, which is cold rolled. So I'm now deciding that I'll go back to Revit, and I know that I've got a material that I created for cold rolled. And it is important that you use the key name that's inside the advanced steel, because with this there was no space between cold and rolled. So when I first did it, it didn't work, and I had to go back and check it, and I went, it's a slight difference there. So it is important to use that key name, not the actual default sort of show name or public name that you might see, which is slightly different here in this case. So materials mapping can be a little bit tricky. It can cause a little bit of frustration. I've seen that. Just a case of a little bit of pre-planning, I think. It will map anything to anything, but then you can have a map in one way and a map out the other way, so it can get a bit confused sometimes. I find, well, more for the users than the system. I think the system knows what it's doing, but the users can get a little bit frustrated with it swapping the materials out whenever you run a sync dialog. So we'll finally just select these, come under there, type cold rolled in the search filter, select that, okay, and they're now changed. They will sort of be blue in colour as well. Then go to the SMLX and press the transfer file again. So especially just check the settings, dynamics still set, yep, that's good, and then go out again. So again, just give it a slightly different name, just so that I can track it. I'm going to come back into my advanced steel. Just going to create a new file with the different materials in it. When obviously the objects are imported, come back to the import button. That one, open. And then if I just go down and check the materials variously throughout the model, you'll see that the columns here, the sizes to come from the JO material there. This is now a dynamic profile, so it should only have one section listed under the drop down here, because it's dynamic, but the material does say cold rolled. Steel, cold rolled, so it came straight across. So just try and watch out for that. Try and watch out for materials. It can cause a little bit of trouble. It seems a small thing, but it just can make life a little bit easier for everyone. So we sort of mentioned earlier on today about approved families. So what is an approved family? So they were linked to a standard structural shape in Revit, and during 2018 they did release an update during the year to update the standard families, and it wasn't easy to find. It didn't put it in the same place. In 19 they've actually brought it all in under one place, so it's under the Revit file, the AU2018 folder, and it's all under the, whichever country you're in, you'll find it in there. So obviously the approved families follow the shape codes, etc., and they do have all the dimensional data, and importantly they have the section key in them. Also they have a number of families or steel shapes that they support, and again I've tried to put a couple of hyperlinks in the page here, so that if people have got the PDF online electric copy, they should be able to select that and just go and see the help pages. But if you can, try and use an approved family. It does make your life a lot easier when you're trying to get from Revit to Advanced Steel or vice versa. So the next big sort of thing that's come in the last couple of years is the improvement with connections. So we've seen connections sort of coming in sort of various stages over 17, 18 and 19 now. 19 they moved on to the steel ribbon tab, and also on the structures tab. I think there's 130 standard connections now, and they are transferred as part of the SMLX. And as of 19 there is a slight change in the way that they are transferred, and it changes the actual beam that they're attaching to. We see this new steel fabrication format that comes into play. The important thing is these connections are exactly the same as the connections and the dialogues that you would see inside Advanced Steel. So people that are familiar with Advanced Steel should be quite familiar in how to use these connections and how to set up the parameters, etc. Copying them is very simple. It's very similar to just copying objects inside Revit. We use the same process to do that. And they do transfer backwards and forwards. I've tested quite a few of them, and they seem to come backwards and forwards quite well, showing all the bolts and welds. So a very high level of detail. If you want to view connections, my tip would be just make sure that you look at them in the fine detail in the drawing view that you're looking at, and then you will see all the detail. So a little bit more about the new tools and how that affects the transfer method. We sort of briefly mentioned that in the previous slide. So with 19 coming, we had the new steel tools. So we mentioned this right back at the beginning, but basically knot, coat, mitre, shorten, replacing a lot of the standard tools that you would see inside Revit for doing the same sort of functionality. And these, when you utilise these tools, which people with Advanced Steel will be familiar with, they sort of link to tools that we've seen in the Advanced Steel palette, which you can see on the right hand side there, and then there's a little snippet of the little toolbar that's now available, sorry, the ribbon tab that's available at the top there. And these fit very nicely into those people familiar with Advanced Steel and provide a very good collaboration between the two platforms. And they are the basis of what is the custom connection inside Revit as well now, where you can build your own joints and that, and you can copy them around the model from first principles. And there's a couple of good blog posts and links out there for people to look at and find out a bit more about this. But the important thing to remember is that it does influence now when you apply one of these features or connections. It actually changes the steel into the new fabrication format. So again, a little bit on the fabrication format here. So I've done a little video showing this. So it's the same model again. I'm trying to keep it pretty simple, not to make it super complicated. But I'm just going to put some connections on in this model. I'm going to use the new toolbar, I think, to do that when I come through to do this. And we can see how this will then change the column. Now, so remember this model earlier on, we actually exported this with these columns, and this came across as normal columns inside Advanced Steel because it looked and it saw those as part of the Advanced Steel database. So here I'm going to go and look for a base plate connection, so I'm going to use the search tool. So obviously I'm familiar with the naming because I've worked with advanced steel, so obviously if you didn't know what the naming was, you'd probably have to scroll down the list. So it will put the connection on the bottom there. I think I do copy and add some more in. I might do a different type as well. So I'm going to go back to connection again. So I'll put another base plate on there. And I'm probably going to come and connect some of the beams together at the top as well, and just see what difference that makes to the situation. So these are quite familiar tools to me actually. I've used these for quite a number of years now. So I know how to operate them and set them up. So this would be quite good for people who are familiar with advanced steel. They'll be able to work within this platform as well as within advanced steel as well. I think at the moment advanced steel is still slightly quicker in doing it. There's a few other little bits and pieces they've got to get in, but we definitely see there's a clear pathway for working between the two platforms, and with the ability to come in and bring the joint in, bring it as a dialogue, and then modify it, and then have that come out the other side as well. So if someone has done something to give an indication inside Revit as to what they want as a connection, then you can use that basis and copy it around in the model, even if you're completing the steelwork detailing inside the advanced steel platform as opposed to the Revit platform. And then you get the other basic steel tools which give you the options to create stuff from scratch. So I'm just changing the dialogue here, moving the bolts around, moving the plate around, changing the bolt centers vertically I think at the moment, and changing the intermediate distance there. And you can sort of see everything altering in on the right, on the left there, sorry. You know, all the plates adjusting, the bolts have adjusted. Let's cut back the beam, etc. So this is the beauty of connections to me inside the advanced steel. They do work very well. Once you just get behind things and look at the dialogues and that, you'll be fine. So we can still see those, they look like normal steel beams, but they are actually changed into what's called the fabrication format. I mean, it's not been widely publicised that I found. And I'm going to leave the export as dynamic ticked, okay, so that'll pick up my other C sections. I'm going to export the file again. Just going to create another one, so with obviously name it with connections. And the dynamic setting, save that. I'm going to swap now to my advanced steel. Just pop in a new file again. I'm going to go to the import button then. Just need to map this material that's coming. So you can see I've got the whole materials database here to choose from. I'm just going to go and pick a material in a minute. I think I'll just go and pick 2355. That will actually create a mapping inside the database actually when I do that. So now you can see it's come through. You can see the connections come through on the bottom. Those are still joints inside advanced steel, and we can see that it's actually affected the beam now. It will have changed it. So that one still stays as it was. Okay. You come to the other one that's got the connection on the end of it, or the column even, that's got the base plate on it. If you go back and look at it, it will change it to the fabrication format, and it does bring it in as a dynamic beam or column. So that is the way it's working. It's just something to note really. I don't think it affects anybody because it still brings the beam across, and if you want to change it back to something else you can do that, and I think you'd probably only need to change it if you need to change the size. But if the project has been done via the engineer and they've already set everything in place and you're just completing stuff or just trying to get fabrication drawings out, then, or you want to change the connection to something that you might want to use, or there's a change in the connection, you can come in and access it. So it should, all the other functionality post modeling should work as far as I can tell from what we've had a look at. So it's just to watch out for that when it comes in. It can be a little bit, oh, what's that going on there? That's a little bit different than what I expected to see. So when we sort of just spoke about this, so when you actually apply connections in Revit, it's called the steel fabrication elements are used inside Revit. It says these particular are that is transferred during this process related to how it deals with copes and shapes and plates and stuff like that. So this is sort of new in the newer version. So there's a couple of help pages on this. So basically this is another change in how the transfer is working in the 2019 version. It sort of subtly creeped in. So there is this new fabrication format, which was brought about by obviously the introduction of the new tools under the steel toolbar ribbon tab. So and it changes it into a new type of element inside Revit as far as I can work out, and it's a steel fabrication shape. There is a couple of help pages on that. If you search for it, you will find them. Again, it works with the supported families inside Advanced Steel. So just note that this method is different from 18 to 19, and there is a new approach in 19, and it can throw you a little bit if you've not seen it before. So the SML structure is different in 19 than it was in 18. So it will, I don't think it will work as a backward transfer now because of this introduction of these new tools for steelwork. And note that once you've actually changed the section to the steel fabrication type inside Revit, even if you delete the connection, that the beam type will remain as that fabrication shape reference. It's not reversible as far as I know. So a couple of ideas for Revit templates in Advanced Steel. I know a lot of people say Revit's all about the templates. So similarly in Advanced Steel, I would try and identify the origin, especially if I was a steelwork detailer, because we advise people in Advanced Steel to do that. Put a little marker down for it. I would use levels where possible in both platforms, to be honest. It helps when you transfer the beams, they do come backwards and forwards. Grids are transferable, just watch out, you know, you can put them in as a standard sort of thing. Try and make sure you use the standard families. I personally just load all the sections that I would need for a project inside the template. I know this can make the template a bit larger, but to be honest, it's just easier if you're trying to select multiple steel beams rather than going backwards and forwards trying to load a particular steel beam. You're not going to have an idea of what you're doing until you've sort of got into modeling it, so just load everything, in my opinion. That might seem a bit drastic, but that's the way we work in Advanced Steel. Everything is loaded, so that will probably help you. Some more ideas here, so to help you. Steel connections, personally I just load the entire lot that exist. I do work with the steel materials. I do try to map the ones that I need. Any special ones that I keep inside Revit, I would advise that you advise the steelwork detailer you've created those before you send him, or when you do send him the SMLX file, so he can create the corresponding material inside Advanced Steel. It will just make it easier for him to map it then, and also the reverse of the process when it's coming back out the other way and going back to Revit, it won't throw a funny, it will bring it back in to the material that is in the template that you're using inside Revit. So colours, I mean, I know Revit works differently to Advanced Steel. In Advanced Steel we use layers and colours quite a bit, and obviously I use the materials to represent different colours of sections and joints and connections and bolts. So there's quite a few things you can do there. There's several different approaches to that. You can either do it at the material level or use the visual graphics to override, etc. I'm not going to try and tell people which way they should use it. I'm just going to say you can change the colours if you need to. There's several different ways of doing that. And obviously just make sure that the template you create has a reference name, and you could add it to the preferred list of templates that you want to use and put it in the right order. So if you're trying to model steelwork in Revit, I think you need to have a template that's capable of doing steelwork and set up to do steelwork, and not just a plain structural template. I think you need to do a little bit more. One note about levels that I meant to mention was that sometimes I found it's better just to have, if you're importing from Advanced Steel, just to have the level 1 at the bottom if you've got levels inside the Advanced Steel model, or else you end up having offsets from the level. So sometimes just better just to have the level 0, work about the 0 option. A couple of things inside Advanced Steel that I wanted to sort of mention as well. There's a management tool setting that we do change in the UK, so you don't need to number the model. It's just the export ASIS body one, change it back to 0, and you won't need to number the model. You will be able to import and export. As I said before, use levels inside Advanced Steel as well as you do inside Revit, and just make sure that you have them. If you do have levels in your model inside Revit, make sure they correspond before you import, or else I've found it does bring it in at a large offset. So maybe just have one at the bottom, call it the same name, and it'll bring it in. Try and use the stuff about the 00 world option coordinate point at the moment. Alright, so it just makes it easier for the transfer of the files from one platform to the other. I know there's offset coordinates available inside Revit. We do try to teach people to model about the world coordinate inside Advanced Steel. Obviously work in progress there. I've had a quick look at that, and I did do some training with someone last year about that. So I do think it is possible to work a bit differently, but at the moment try and use the origin the same way in both platforms. And sort of bringing to a close here is just a little video that I was having a little experiment myself. I modelled this structure from scratch inside Advanced Steel, and wanted to see what I could do and what I could get from Advanced Steel back into Revit in 2019. And this is going to use a Medsec cold rolled family, which does exist as a standard connection inside Revit. I was looking at the new connections to bolt cages that are done for Australia there. I just wanted to see if they would come across. But I put standard base plates connections on. All these are all standard joints that are available inside Advanced Steel, and I just wanted to see whether they would come across into Revit, or at least I would at least get the plate and the nut and the bolt with it, or the cleat. And I put a little test level in. I put that beam that's in there, the header beam of the door, I put that in at level 3 inside Advanced Steel. So I've got levels in my Project Explorer on the left hand side of the screen. There slightly different brace tube based connections in the roof, just to see if that would work from the normal ones we would use in the UK. So with that, I've sort of, throughout this process of prepping for this event, this class, I've sort of learnt a few more things myself that I didn't realise about materials and the transfer and the various databases that you use, and the method and the process associated with it. So now we're going to go up and we're going to go to the export import. I'm going to export it in this case to Revit. I'm going to create a new file. I'm going to overwrite the file that was in there I'd already created. And then I'm going to, you can see it progressing across the bottom right hand side of the screen. I just saved the model. That's a standard sort of dialog that pops up. You can see a version of the model I did earlier on when I sort of started. So I'm creating my new template. So this is my custom template I've done inside Revit. I've got a couple of levels in there. I'm just going to put it around to a similar sort of home view. You can see I've got a little place marker for the origin. I'm going to come to the Manage tab. I'm just going to check my materials. I think I'm going to go and change the material. See the cold rolled in there. Okay, so I'm just noting the cold roll that was in there. So I've added that in. So that's the JO1 that I had in the model before. I think I'm going to look for S275 now that I created before. So I've got a few families already loaded in here. Now when you import from Advanced Steel, it will pull in what it needs to pull in. If you don't have it loaded, it will bring it in. I have found that as well. So you don't have to have everything loaded. It will bring it in, or it will bring up a mapping dialog, and if it's not sure what it is. So I'm going to go, here we go, yeah, the Portal 2. Now it does take some time to do this normally. So it might take a few minutes, so just wait for it to do it. It tends to bring it in, and then you sort of see it processing. It sort of flips a few things, changing the background, so it is working away. So I've got a slight warning message at the moment. To be honest, I think I got that to do with the connection elements. So that was, I think, actually to do with the Australian bar was one of them. So I just ignored those for now. I just wanted to see what would come in. So it just takes a few more seconds for it to initialize. So that's the same model. I brought it into Revit. To be honest, it's used a standard Medtech family that existed. We got a few little glitches with it at the moment, but generally I've got quite a high level of detail across. I think I even got my shim plates, so my concrete bases, my connections at the haunches and stuff. Obviously the colours don't have to all be this garish. I just made them like that for today. It's up to you what colours you use. So quite a good level of detail, quite a good level of transfer. Was quite sort of pleased with that, to be honest. So just having a little look around the model. So sort of this was a sort of first attempt at trying to do this after a few attempts of trying to work and understand some of the stuff working in the background. So I just wanted to show this. I mean, it's not totally 100% perfect, but I think I'd be quite pleased to see that inside Revit compared to some of the previous years when I've been trying to transfer stuff backwards and forwards. And we can obviously see that this is the clear direction where we're going with this collaborative workflows. So that brings to a close today's presentation on the workflow between Advanced Steel and Revit, Revit and Advanced Steel. Hopefully you found it interesting with a few tips and tricks along the way about how to get backwards and forwards between Advanced Steel and Revit. And you can see the vast improvement made in the 2019 version. So I hope you found this informative and helpful, and hope it'll inspire you to have a go and try and get this mechanism working within your company, and even within your working group between your engineers and your detailers, to help smooth your project through. Thank you.